Today's lesson is called Rational Exponents. We are going to be looking at exponents and radicals today and answering the question, what is the connection? So I want you to complete the following questions in your groups. Now you are watching this video, so you are not able to work with groups. You're going to do this individually. And please use your calculator to complete the provided table of values. So you're going to see two graphs. Each have two equations. You will graph the same equations on the same grid, so you'll have two things. You have two tables to fill in, and then underneath the tables, there are questions on what you notice. I want to talk to you quickly about the graphing calculator so that you're aware of some of the things that you might run into and you might need. So please take out your graphing calculator. I am going to use a version of it on my iPad. I'll do the best I can to kind of point out those buttons to you, and you can follow along on your graphing calculator. You are going to start out by going to the y equals button in the top left corner. That will get you to the area where you can type equations that you need to enter. Now, the square root symbol is on the keys. It's above the x squared using second. However, at some point you will be asked to do the cube root symbol, and I want to point out to you that that is under the math function, so math. And then if you go either down with your arrows or pick the number that you want, and you pick number 4, it will put the cube root right in the position for you, okay? Another one that you will have to use is a fraction in the exponent position. So I want to talk about how you will do that, okay? So if you're going to use a fraction in the exponent position, first we'll have to start out with our variable. So we get our variable by going to the key right to the right of alpha. If I hit that button, it gives me an x. Now if I need an exponent, if it's squared, I can use the x squared key. If it's not squared, I have to use the caret function, which should be for you right above division. Okay, right above division. That will put me in the exponent position. And then when I want to enter a fraction, I'm going to hit alpha and y equals, and that will give me this pop-up menu at the bottom. Mine looks slightly different because I don't have the numbers, but you should have numbers 1, 2, 3, and 4 for the different types of fractions. We are going to pick number 1 for a fraction, and you can see it makes it create a fraction on your screen. Now, if I want to type in something like 1/2, I can do 1, use my down arrow to get the denominator, and hit 2. Now, whenever you are graphing these lines, I want you to get in a good habit of not hitting graph at all. I want you to hit zoom, and then choose option 6, which is your standard window from -10 to 10. And when you do that, a picture of the graph will pop up. It is hard to determine the exact points from these graphs, so that's why we have our tables. And you get to table by hitting second graph, and that will take you to a table of values that you can refer to. So at this point, would you please pause the video and complete the two graphs, answer the questions, and then when you're ready, you can resume the video and go over the answers with me. Okay, let's take a look at the first set of graphs. We are going to look at y equals x to the 1/2 and y equals the square root of x. So we're going to start with y equals x to the 1/2 power, and your table of values should have read 0, 0, 1, 1, 4, 2, and 9, 3. So when we graph these, here's 0, 0, 1, 1, 4, 2, and 9, 3 should look familiar to what we saw on the calculator. You should be connecting them from that value and to the right, and we'll talk about in a minute why I don't have anything to the left of the y-axis. So again, this is your x-axis, this is your y-axis. And we are going to label that with y equals x to the 1/2 power. Then we're going to complete y equals the square root of x. So that is 0, 0, 1, 1, 4, 2, and 9, 3. And so when we graph that, it ends up laying right on top of the graph we already created. So I'm going to label this with y equals the square root of x. So hopefully what you noticed is they create the same graph. Now, in addition, I want to talk about the fact that nothing is to the left of the y-axis. And we're going to talk about that by going back to our calculator and looking at our table. If you see where the pink box is, you notice that is 0, 0, and as the values increase, we still have numbers. It's just that we have some ugly kind of decimal numbers in between, and I've had you write down the numbers that were more easy to graph. But if you look at -1 and below, you're going to see a bunch of error messages. So let's take a look as to why that's happening. This is a square root function. If I put a negative underneath the square root, we are going to get an error message. We cannot take the square root of a negative number. So no square root of a negative number. So you're going to notice we don't have any negative values for x. So no negative values for x because of that. Now for y equals x to the 1/3 power, you should have had -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So we'll go ahead and plot those points. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So we end up with this snake-like curve. And we're going to label that with y equals x to the 1/3. Then, y equals the cube root of x. You should have -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. So just like in the previous graph, we end up with a graph that falls right on top of our original. Or our first one, I should say, y equals the cube root of x. And again, for our answer to what do we notice about these graphs, they create the same graph. So now let's get into our key concept as to why this is happening. Writing something with a radical and writing something with an exponent that is a fraction are similar to each other. They mean the same thing. So when you're looking at this diagram, okay, whatever number is in the top of the fraction in the exponent position is the same number that should be on the x underneath the radical symbol. The number that's in the denominator should be the same exact number that goes outside as the root of your radical. So the cube root, the 4th root, the 5th root, the square root. When it's a square root, though, we do not write the 2. It's implied, okay? And then you can also see on the other side where those numbers go. We still have them in the root, and here we still have it as the exponent, okay? So rules that we've previously discussed, you did this in summer review, and you did it in the previous year. There are rules for when we have powers with the same base. So on the left-hand side, you're going to see a chart of a review of your exponent rules. The product rule is when you're multiplying, you keep the base and add the exponents. For quotient, you keep the base and subtract the exponents. For a power to a power, you multiply the exponents and keep the base. If there is more than one letter in the base, make sure the exponent goes to both pieces. And the same thing for a fraction. Make sure the exponent goes to both pieces. Remember, all of these rules are when your bases are the same. So let me prove to you why this special situation is happening on the other side in this box that says, using the laws of exponents, let's see how rational exponents behave like integer exponents. So if I take b to the 1/2 and I square it, b to the 1/2 counts as my base. So that means I'm going to do b to the 1/2 times itself 2 times. Okay, according to my exponent rules, I should keep my base and add my exponents. So that's what I'm doing. And that means I get b to the 1st, or just plain old b. We don't need the 1. Okay, now from what we just learned, b to the 1/2 means the m, remember, is the exponent on the b. So that's b to the 1st. And the number on the bottom is what root we're taking. So we're taking the square root because that's a little 2. So b to the 1/2 is the same thing as the square root of b. This is the square root of b. And what happens when you take a square root and times it by itself? We've talked about this. That means the square root symbol is eliminated because what you're getting is the square root of b squared, which is just b. So that proves to us that b to the 1/2 is the same thing as the square root of b. Okay, so now let's go through some examples of how we can transfer back and forth between the different types. So in example 1, we're going to write the expressions in radical form, or we're going to write each radical in exponential form. Okay, so if I have 25 to the 1/2 power, remember the number on top is the exponent on the number underneath the radical. So that would be 25 to the first, but when it's a 1, we don't need to write it. The bottom number is what root we're taking. So if it's a 2, that means we're taking the square root. So 25 to the 1/2 is the same thing as the square root of 25. If we look at example 2, that is the square root symbol, which means there's really a little 2 out here, but we don't need to write it when it's a 2. So that tells me I'm going to take 18 and put it to a fraction. It's the square root, so a 2 goes on the bottom, and on the inside, the exponent on 18 is a 1, so the 1 goes here. So the square root of 18 is the same thing as 18 to the 1/2 power. Now when we look at number 3, it's very similar to number 1, except for we have a 5 in front. There are no parentheses, so that means the 1/2 only belongs to the x. So the 5 will stay where it is, and x to the 1/2 is the same thing as the square root of x. In number 4, the 8 and the p are underneath the radical. So when we go to write it in exponential form, we have to keep the 8 and the p together in a set of parentheses. And since it's a square root symbol, I know my exponent is 1/2. Okay? Now let's take a look at example 2. Write each expression as a radical and then simplify it. So we're actually going to simplify our expressions when we're done. And I'll talk to you again on the calculator about what to do for certain roots. So 125 to the 1/3 power means we're going to take the cube root of 125. So that means what number times itself 3 times gives you 125? That answer is 5. Now if we want to use our calculator, remember, we would go to the math key. We would pick option 4, because that's cube root, and we would enter 125, and that's how we're getting an answer of 5. Okay, let's look at number 2. Number 2 says 1,296 to the 1/4 power. That means we're taking the 4th root of 1,296. Now let's go back to our calculator. If we go to math, you're going to see there's no 4th root option, but what you do have an option for is what you see in number 5. There's a little n in that position. That means we can pick any root we want. All right, let's find out what the 4th root is. So we are going to hit math. We are going to pick choice 5. And you'll see there's a little blinking cursor there that's going to allow us to then hit a 4 and enter that number. Now, for those of you without the TI-84 CE edition, if you have an older edition, you might have to type the 4 first, then do math and choose that option and go back to the screen and hit enter. Okay, so now if I arrow over, it'll take me underneath and I can put in the 1296 and get my answer of 6. Okay, in number 3, 256 to the 1/2 power means we would take the square root of 256. And then depending on directions, your answer could be a positive or a negative 16. Okay, most of the time they ask you for the positive square root, but technically negative 16 times negative 16 is 256 as well. Okay, and our last one, 27 to the 1/3 power, wants the cube root of 27. So what number times itself 3 times gives you 27? That's 3. And that concludes our lesson on rational exponents.